Servus. Today I want to dive into left shift your SLOs with Chaos. And we dive into an SRE tale, obviously. We started adopting SLOs or service level agreements, objectives, and indicators with different aspects of tracking availability and also defining error budgets. And from there, it was not far to so-called golden signals defined by the Google SREs. We had latency, traffic, error saturation as an indicator. And at some point, we needed code instrumentation. So maybe SRE solved everything. Yeah, maybe. But switching roles a little bit into a developer, and you might remember that from my talk last year, where I told you about, hey, I needed to debug a software and it crashed a lot, but only in production. It was quite exhausting, and I also burned out from debugging this problem. Especially because it behaved differently on different platforms and so on. And in a retrospective, I really would have loved to have ops requirements being met, like monitoring the stack and heap memory, defining the SLI as the mem usage level and the SLO maybe as a 10% increase throughout the development process in CI/CD merge requests and later on in production deployments. And I also was thinking of maybe using some sort of chaos engineering and fuzzing for API requests. Another story brought me into also thinking about SLOs and chaos. And this is an ops tale with a spoiler of it's always DNS. In 2011, I was maintaining the .at top-level domain, and we were installing DNSSEC. We had signing hardware, we had a state machine. Typically Friday afternoon deployment, something broke. Production was broken over the weekend. We had no more signing, no DNS updates, and monitoring was going wild. So the thing is, monitoring has alerts, and someone is getting paged, someone is getting called. So the DNS zone serial was out of date. The first alarm was fired by email, nobody read it. Then it got into SMS. You get woken up, and at 5 a.m. in the morning, debugging is not fun. The change was persisted in the Git repository, but we didn't have any sort of CI/CD or quality gates back then. And it kept me thinking, in a retrospective for corrective actions, we might have staging signing hardware for DNSSEC. We might be using infrastructure as code and GitOps workflows for that, and define the SLI and SLOs for the zone serial age and say, hey, when it's older than 1 hour, we need to alert, we need to do something about it. And also thinking a little bit about chaos engineering with the name servers, like denying zone updates, returning different zone serials, diving into that. And so when thinking about these stories, how can I really get there, and what is needed to really adopt SLOs? So as an SRE, DevOps engineer, where do I actually start with SLOs and then chaos engineering? For SLOs, let's look into monitoring. We have metrics, we have key or tags with values, and what else is in there? And one of the things where I got hooked into was, okay, let's use Prometheus and PromQL for queries. Look at the format, learn how to query the metrics and the data being stored. And from there, we can navigate into adopting service level objectives. Now, there are different metric sources to keep in mind. So ones that might exist in the infrastructure, like memory, CPU, I/O, using an exporter on the node, pod, or Kubernetes cluster. There might be services being exposed by Prometheus exporters. And for own applications, we need to add that into the code, like using app instrumentation. When we have the metrics, we need to do something with them. And using PromQL for alert rules, which trigger the SLO, is one way to do it. So you're defining the allowed errors in the error budget and define when the SLO is violated and to alert. And this is basically how we can adopt SLOs for later on. Now, what can we do with an SLO? we can measure it with Prometheus and, for example, combine it with Captain as a quality gate so that we measure the application performance and insights in a staging environment using the quality gate to not deploy it into production, for example. Now, with quality gates, we can adopt the continuous delivery pattern as well. So like ensuring that production is in a safe environment. The thing is, simulating a production incident is really hard. So you want to see how the app is behaving. We can add chaos to our staging environments and also to our production deployments and see how the application is behaving. Now, this brings me to shifting left with chaos, which means, like, again, similar to metrics and SLOs, we need to understand where to go. And as an SRE, DevOps, or whatever your role title might be, start thinking about cloud native clusters. You have deployments. Inside these deployments, you add the chaos framework, which allows you to run experiments. And if you need to dig further into it, you can actually use instrumentation SDKs, create your own experiments, extend what is out there already, and can be used. One example is to use Litmus Chaos, which is a cloud-native computing foundation project. And it helps you to fail your infrastructure and the Kubernetes cluster, for example. You can see how the application is behaving, whether it crashes or lags or does something else. You can measure the metrics and the SLOs and see if they still match. And from there, you can define actions and improvements to iterate on your observability workflows and specific other things you might be missing. This is helped by so-called experiments and workflows, which allow you to also visualize the experiments and add chaos to your deployments. Now, thinking about the stories I told you before, like what is needed to really add chaos to your deployments, like as an SRE, maybe adding something which is a CPU overload, or HTTP requests are getting blocked, so the golden signals become available again. As a dev who's struggling with REST APIs and building software, maybe simulate something where API clients are not closing the connections correctly, or something is intercepting the DNS traffic or something else. For ops, think about intercepting DNS traffic, obviously, or just break it somehow, and ensure that it doesn't resolve, and see how the deployment, the application, the Kubernetes cluster, and everything else is behaving. Super interesting, by the way. And for DevOps, think about container registries not allowing to pull or something else. This could also be taken into account into really adding chaos to your deployments. Now that we want to shift left, or do the left shift, just to recap it a little bit, we want to have observability everywhere. So collect the metrics and think about adding more events later on. Learn about app instrumentation and also educate your DevOps teams, because you need to deploy that into your CI/CD pipelines, for example. So you want to define and measure the SLOs before they are actually being deployed. And you can also benefit from cloud-native environments and the cloud-native ecosystem, because the deployments and other things happen with autoscaling in the Kubernetes cluster, for example. And there are many projects out there which integrate with each other, and you can learn from the best practices. So, for example, Kubernetes added Prometheus monitoring and metrics, and you can inspect the source code, you can see the pull requests, and learn from that, and get into the documentation how it's being used. Similar thing with OpenTelemetry and Litmus Chaos and so on. When you want to left shift with chaos, bring chaos into observability, see how it behaves, verify the SLOs and quality gates, and also ensure that reliability is there. Iterate and innovate. From there, the wishlist, or my wishlist, is correlate things and use machine learning to maybe make it easy for us, add chaos out of the box, make it accessible for everyone, and ensure that OpenTelemetry gets wider adopted, for example, for CI/CD observability. With that, thanks for your attention. I would encourage you to check out o11y.love to learn more about observability. And yeah, have a great day. Go slow.